So this is part two for the pre-calc review. Let's see, module two, module three, lessons 1 through 8. Sorry, I looked at my other class for a second. So let's continue. So what is the third term for x plus 4 to the 10th power? Okay, well, the first thing I need to do is think about what? Can you guys remember? What do I need to think about first? Pascal's triangle, right? So let's think about Pascal's triangle. And we're talking about the 10th power. So if we go to Pascal's triangle and we think about row 10, remember we start at 0 and go to 10. So row 10 right there, what's the third term? 45. Now, I also want to make sure you understand this, that if I'm talking about this row, it starts from 0 as well. So because we're talking about the 10th power, it's actually 11 numbers there, okay? Because we're on the 10th row, talking about the 10th power. We start with 10 to the 0 power, 10 to the 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So technically, the the third term, we would be using 2 for that. Now, let me explain what I mean by that. Because when we were talking about combinations and um, uh, man, I can't even say the name. Permutations. Thank you, ma'am. Thank you very much. So we could find out what the constant was by using a combination, right? So the combination is n factorial time or divided by p factorial times n minus p factorial. So if I did that, I could get the constants from Pascal's triangle. So if we're talking about the 10th power, that means my n is 10, right? I'm talking about combination. So then what will my p be? Well, I think about from 0 to 10, those are my numbers. So if I'm talking about the third term, it's technically 2. Does everybody understand what I'm saying? If I was trying to use the combinations to get if I couldn't get Pascal's triangle and I just had to use a computation to get that number, it would be 10 and 2 because I'm going 0, 1, 2. Okay? And then, I mean, I don't need to really do this because we already know it's 45, but it would be this, right? So I'd have 10 factorial over 2 factorial times 8 factorial, right? And so then 10 factorial over 8 factorial, I'd have 10 times 9. I just said I didn't need to do this, and I'm doing it. 8 factorial over 2 factorial times 8 factorial. Well, the 8 factorials cancel each other out. So what am I left with? Well, 2 factorial is just 2. It's just 1 times 2. So I'd have 10 times 9, which is 90, over 2, which is 45, like we just said. And so 0, 1, 2, so the third term, my Pascal's triangle's constant is 45. Okay. Okay, so we go to the 10th row of Pascal's triangle. If I counted from this term to that term, there's actually 11 there, even though we're talking about the 10th power, because they start their count at 0. The same way up here, I said row 10, right? If I count down, that's actually 11 rows because we start our rows at 0. Okay, so 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. You get it? Excellent. Yep, I actually said it. You just didn't. And so, see, yeah, and let's record this conversation as well. So, what else we got to say? You sure? Okay. So, I'm so glad that you get it, ma'am. Just glad it wasn't a conversation with Marcus. So anyway, so now what do we need to do? Okay, let's think about what happens with x plus 4 to the 10th power. Well, I start, my first term is the first term to the 10th power times the second term to the 0 power. So I start with my power for the first term for the highest number, and then my second term is going to start at 0, and it's going to work its way up while the first term is working its way down. Does everybody understand what I'm saying there? So when I look, this is the first term. So then my second term, so I'm going to say plus. So then I'm going to have x to the ninth power times 4 to the first power. My powers are going to add up to be 10. So 10 plus 0 is the first one. 9 plus 1 is the second one. But we want to get to the third one. So I'm going to say plus, excuse me, x to the eighth power times 4 to the second power. So this is where my third term lies. So I'm going to multiply 45 times x to the eighth times 4 to the second power. Does everybody follow where I'm at? Ma'am, do you understand? Marcus, do you understand? Okay, excellent. So I need to multiply these. So that's going to be 45, 45 times 16 times x to the eighth. Well, nothing's going to change x to the eighth. That's going to stay the same. But off the top of my head, I don't know 45 times 16. So it'd be really nice if somebody had a calculator and multiplied that out for us. What is it? 720. Excellent. If you're trying to be nonchalant, you need to not say it so fast, sir. You know, because I didn't know what that was. But I do understand 720. So it's 720 times x to the eighth power. That's my third term. Does anybody question, anybody question? No question? Okay. So let me erase this, and we're gonna come back because we need that. So let's hurry up. Yep, we need that. Okay, y'all gonna make my hair hurt. So we put it there. Here's my combination formula because we may need that. Okay, consider the expansion of u plus v to the eighth power, right? So find the coefficients. So that we want the coefficient, not coefficients, coefficient. We want the coefficient of, I'm gonna have to make sure I change that. We want the coefficient. So when I got u to the fifth power times v to the third power, does everybody understand what's going on there? Because taking this to the eighth power, there's no numbers in there. So really, my variables themselves, when I add the exponents, they add up to 8. So I've got u to the fifth and v to the third. So we're going to start at u to the eighth, v to the 0. So that's my first term. Now I'm sure there's probably a more efficient way of figuring this out, but I'm just going to go it a long way. So then I know that u to the seventh, v to the first is my second term, right? And then I've got u to the sixth, v to the second. That's my third term. And then I've got my phone's ringing. Mr. Ferguson's room. Hey, um, you mean before lunch or do you mean after lunch? Okay, so like now, okay, I'll let her know. Yep. All right, bye. Um, Miss Miss Ella, Miss O would like you to come down. I'm recording this, so that conversation was also fun. So anyway, five or u to the fifth power times v to the third power. That's the fourth term. So I want to know what the constant is for the fourth term. Does everybody follow my logic there? Okay, I know that when we're doing this expansion, right? When we're taking like, let me just do something simple so you can get where I'm coming from. I want to expand that, right? So I take u plus v to times u plus v because that's what u plus v to the second power, and I multiply those and I get u squared plus 2uv. That don't even look right. You know what I mean? Plus v squared. That's the expansion of this. So when I'm getting the expansion of to the eighth power, it stretches out, right, a lot further. So the pattern that we see that happens is when we do that is that my first term starts at the exponent, the highest number that we're dealing with. And then the second term, it starts at 0. The first term goes down in exponent. The second term goes up in exponent. So that's why my first term was u to the 8th times v to the 0. Well, v to the 0 is 1. So that first term is only going to feature the first term, or the first of second, right? So so then as I go along my lines, I got 7 and 1. Then I got 6 and 2. Then I got 5 and 3. Because when I add the two exponents, I get the power that I started with, 8. So that would be my first term. The first one went down, the second one went up. First one went down, second one went up. First one went down, second one went up. So if I want to find the coefficient, what number needs to go in front of here for that, right? That's what I got right now. So now what's my coefficient? Well, I got two choices. I could look at Pascal's triangle, or I could do this. Now remember what number my p is if I'm looking at the fourth term, because my count starts at 0. So what's my p? 3. So my p is going to be 3, and my n is going to be 8, because 8 is that exponent. And so I've got 8 factorial over 3 factorial times 8 minus 3 factorial. So 8 factorial over 3 factorial times 5 factorial. So that's 8 times 7 times 6 times 5 factorial over 3 factorial times 5 factorial. Well, the 5 factorials cancel each other out. And I got 8 times 7 times 6. But 3 factorial, what is 3 factorial? It's 1 times 2 times 3, which is, like the lady said, is 6. So I'm going to have 8 times 7 times 6 over 6. The 6's cancel each other out. And this time we don't need somebody with their magic calculator, because 8 times 7 is 56. Right? And so that's the constant that we're looking for. Find a constant for that term. That's what they mean. Does anybody have any questions on that? Does everybody understand what we did? Yes, no? I mean, if you got questions, we can talk about it. Okay, so that's that one. Then let's keep it moving. All right, find a vector f of g given the initial point. So this is in 3 dimensions. Given the initial point f and a terminal point g. Remember what initial and terminal mean. You know, initial is where you start, terminal is where you end. And as far as the vector, we can treat the vector like distance. So we're going to look at the initial point. That's what we're going to subtract from our terminal point to see what the distance was, to see how far we went. So I'm going to take g and minus f. So I got 5, 3, and negative 2 minus, let's see, what is that? 2, negative 1. Yep, so my vector for gf is going to be 3. 3 minus a negative 1, that's a positive 4. And then negative 2 minus 4 is negative 6. So that's going to be my vector for FG. 3, 4, negative 6. And now I need to find the magnitude. Well, what's the magnitude? Well, it's like I run the distance formula on that thing. I take the square root of my first term squared plus my second term squared plus my third term squared. Oops, squared, sorry. Yep. So that's what I'm doing. I'm squaring FG. So that's going to be the square root. So the magnitude of FG is going to be 3 to the second power plus 4 to the second power plus a negative 6 to the second power. So that's going to be what? 9 plus 16 plus, no, it's going to be 36. Because remember, when you got a negative number and you take it to the second power, it's a negative 6 times a negative 6, so the negative cancels off. So anytime you're dealing with squares, second power, it shouldn't be negative unless you're in pre-calc and you're dealing with I. Because if I take 5i to the second power, the I square makes negative 1. So that's how I could get 5I squared is negative 25. So anyway, I'm starting to go down a rabbit hole. So let me lock in. So so I'm gonna have, what is that? 61. Yep. So that's 25, right? 25 plus 36 is 61. Is 51? 25. Yep. So it's 61. So the square root of 61 is the magnitude for f g. All right. So this is my vector. So we need both of those. And I would suggest that you maybe circle it or something so we can see what, make sure we know what the answers are. Differentiate from the work. Okay. Any question? Question? Anybody question? You do that a little nicer so it don't mess up my problem down there. Okay. So next, let's hit up changing stuff from rectangular form to polar form. Rectangular form to polar form. Yeah, this is definitely a review, but it's been a minute, so let's do it. So rectangular form looks like x plus y times I, right? That's exactly what we got up there, right? And in polar form is r times cosine of theta plus I times sine of theta. So what do I need? I'll keep going. Y'all do what y'all do. So what do I need? I need r and I need theta. So I think, how can I use x and y to get r and to get theta? Well, r equals, like the distance formula, the square root of x squared plus y squared. And then theta, using x and y, is tangent inverse. So the inverse of tangent of y divided by x, right? Y divided by x. So then let's figure out where we go from there. So I just do some plugging and chugging right now. So 4 is my x, and y is 4 times the square root of 3. So to get my r for this problem, right, it's the square root of 4 squared plus 4 times the square root of 3 squared. So what is that? Well, it's easy to know 4 to the second power, that's 16. But what is 4 times the square root of 3 to the second power? Well, I know 4 to the second power is 16. So that's 4, I'm sorry, that's 16. I got that. But what's the square root of 3 to the second power? Well, a square root of 3 to the second power, well, remember, square roots and squares are opposites, right? They're opposites. So then what happens? What I end up getting is 3. So I'm going to have 16 times 3, or 48. So now I'm going to have r equals 16. Man, I'm running out of room here. Let me see if I can consolidate a few things, make this a little easier. Come on, quicker, quicker, Ferg. Okay, so let's rewrite that. So I said r equals square root of 4 squared plus 4 times the square root of 3 squared. And so r equals the square root of 16 plus 4 times, or sorry, I keep saying 4. 4 squared, which is 16. So 16 times 3, because the square root and the square cancel each other out. So that's going to be r equals 16 plus 48, which r equals the square root of 64. And what's the square root of 64? It's 8. So I know what my r equals. R equals 8. So now I need to find my theta. So I get my handy dandy calculator and say, what is the inverse of tangent of, okay, so my y is 4 times the square root of 3 over 4. Well, if you notice that those 4's, because this is just a fraction or a division problem, so the 4's cancel each other out. So it's really just the inverse of tangent of the square root of 3. Well, I gave you guys unit circle charts that if we go up and there's the phone, if we look for the tangent of, you know what, let's not use that. Let's answer the phone instead. Mr. Ferguson's room. She went to lunch. Oh yeah, yeah, yeah. Okay. Thank you. She came into class late, so I need to update my attendance. Yep. All right. Yep. Bye. Okay. So what we're gonna do instead of that is we're gonna go get a calculator. So we're gonna use our handy dandy calculators. And if we put in the inverse of tangent and say the square root of 3, okay, this person was so nice to have their calculator on radians instead of degrees, so I missed it. So let's try it again. The inverse of tangent times the square root of 3, that's 60 degrees, which incidentally, I guess I need to go back. 60 degrees, same, yada yada. So anyway, so that means my theta, so my theta is equal to 60 degrees. So now I need to change 60 degrees to radians because we've been using radians for this. So guess what? If you forgot, 60 degrees in radians is pi over 3. That chart is really handy, ain't it? It's right there. Okay. So then I know that this is pi over 3. So now I got my r and I have my theta. So let's finish. Let's put the problem right here. So it's going to be 8. Matter of fact, let's change the color too. So let's say 8 times cosine of pi over 3 plus I times sine of pi over 3. And that's my answer. So now I need to go the opposite way. Now I need to go the opposite way. So I know my polar form. So I'm going from polar form to rectangular form. And you know, I think I'm going to stop the video here because I got to do some stuff before I get fussed at. So let's stop and I'll make a part 3.